when I take a projectile into consideration, so let's say it is projected with initial velocity of u, making an angle theta with respect to the horizon. Right. So it is going to reach a maximum height here, which is given by the expression u square sin square theta divided by rho g. So how did we derive this? So one is observe. So one of the ways in which this can be derived is using the equations of motion. So we use the equations as v square minus u square is equal to 2as, and we applied it along the y direction. Right, we applied this along the y direction, which implies velocity of the object at the highest position is how much? In the y direction is 0. So it is 0. So 0 square minus what is the initial velocity of the object along y direction? See, this is u cos theta and this is u sin theta. So initial velocity of the object along y direction is u sin theta. So 0 square minus u square sin square theta is equal to 2 into, see, if you take the upward direction as positive, g is in the downward direction, so it is minus g into how much is the distance covered by the object? It is h max. So this is the formula for h max. Right. So it is minus u square sin square theta is equal to minus 2g into h max. Except that minus and minus will get cancelled. So what will you get? This implies h max is equal to u square sin square theta the whole divided by h. So this is the way we derive this expression for will be discussed in the fourth chapter. Right. Now, since we know some concepts extra, can we try to derive the same thing using some other logic? Right. So can we try to derive the same thing with the help of energy conservation? So what does the energy conservation theorem state? So kinetic energy plus potential energy at every point should be a constant. So if I take this point to be O and this point to be A, right, observe this carefully. Can I say that the total energy of the object at O should be equal to the total energy of the object at point A? So what are the energy possessed by the object at point O, provided I consider the base to be the reference line, because for potential energy I need the reference line. So what is the total energy at point O? It is going to be the kinetic energy at O plus the potential energy at O. Can I write it as equal to kinetic energy at A plus the potential energy at point A? Can I write it? So what is the kinetic energy at point O? It is half m. You will not write half m u sin theta square or half m u cos theta square. It is a sum of both. It is only half m u square. So it is half m u square plus what is the potential energy of the object at point O? It is 0 because that is the reference line itself is equal to what is the kinetic energy at point A? It's not 0 because it is only the vertical velocity that is 0. E by 2. That will not be the case. So here if you observe, it is going to be u cos theta. There is the horizontal velocity existing for this particle. So though at the vertical point, only the vertical velocity is 0, but the horizontal velocity is still u cos theta because that is constant everywhere. The object does not accelerate along x direction. So can I write this as equal to half m? Since this is the only velocity existing, so half m u square, so that is going to be u square cos square theta. Makes sense? Plus, what is the potential energy at point A? It is going to be mg into h max. So what gets cancelled? M is gone. So half I will leave it as it is, or half u square I will leave it as it is. So if I take the u square common, here the value is 1. And here the value is cos square theta. So when it comes to the left hand side, it becomes minus cos square theta is equal to g into h max. So what is 1 minus cos square theta? So this implies u square into sin square theta by 2. U square into sin square theta by 2 is equal to g into h max. Bring the g to the left hand side. U square sin square theta by 2g is equal to this are the same. Did you understand this? So what I'm trying to say is, this one theorem is enough for you to solve any problem where there are conservative forces. In the sense, if you don't even know the equation of motion, you can still solve it with the help of energy conservation. Clear with this?